Hello everyone, myself Dr. Ranjith Kumar Gatla, working as an Associate Professor in the Department of Electrical and Electronics Engineering. So in today's class, we are going to discuss some numerical problems on H parameters. In the previous class, we have already discussed some example numerical problems based on Z parameters and Y parameters. So which are impedance parameters and admittance parameters. So now in today's class, we are going to discuss some numerical problems based on H parameters. So these H parameters are also called as the hybrid parameters, which means why we are calling it as a hybrid parameters, because in the previous class we have discussed Z and Y parameters. So the Z parameters are also called as a open circuit parameters and the Y parameters are also called as a short circuit parameters, which means if you want to find the Z parameters, so in the first case, to find Z21 and Z22 or Z12 and Z11, okay, Z11 and Z21. Let us consider Z11 and Z21. So to find Z11 and Z21, so how we are finding? We are making, because I1, okay, so I2 as a 0, so which means we are making the output terminals as a open circuit to find Z11 and Z21. Similarly, to find the other two parameters which are Z12 and Z22, so we are making the input side as a open circuit, which means I1 we are making to equal to 0 to find the other two parameters. Similarly, when coming to the Y parameters, which are admittance parameters, are also called as a short circuit parameters. The same way, if you want to find Y12 and Y11, okay, so our Y21 and Y11, so how we are making, because Y21 and Y11, so we are making here the output as a short circuit, which means there we are making the voltage as 0, the output voltage 0 by making the output terminals of the short circuit. So that's why those are also called as a short circuit parameters. But here, unlike in the Z parameters and Y parameters, in the hybrid parameters, okay, so the secondary side we are making short circuit and the primary side we are making the open circuit to find the H parameters. Similarly, here also in the H parameters also the same way, like we need to find first H11 and H21, then after that we will find H22 and H12, right? So first let us discuss with the go with the first problem. So here by referring the network shown in the below figure, find the H parameters. So here, as usually here the H parameters also 4 H parameters are there. So in the first set we will find H21 and H11, and in the second set we will find H22 and H12, right? So then first we will find H11 and H21. So to find H11 and H21, how we are finding here? By short circuiting the output terminals, which means by making the output voltage V2 equal to 0, okay, and just a connect, okay, current source of I1 to the input terminal, then we can find the H11 and H21, right? Of course, then how to find these H1, what is that, the H11 and H21, right? H11 and H21. So for that here, let me just follow some basic procedure, right? So here it is the circuit to find H11 and H12, right? So for that here, what I am going to do is, just here I am indicating the two nodes. Let us consider here it is node X and here it is node Y. So first let me apply the KCL, okay, that is Kirchhoff's current law at node X, right? So let me apply KCL at X, right? So if you apply the KCL at X, okay, as you can see here, the sum of the currents entering towards the node is equal to the sum of the currents leaving from the node, right? or the algebraic sum of the currents at a particular node is equal to 0, right? So for that here, let me consider here it is minus I1. So let us consider the entering currents are the negative and the leaving currents are the positive, right? Because we have to consider any one of the way, right? So here minus I1 plus, which means here I1 is the current flowing through the resistor RA, and the current flowing through the resistor RB here it is. Let us consider here the voltage is Vx. So I mean I is equal to V by R. So let us consider here it is Vx by here RB plus, because this is the leaving current, and again here I3 is also leaving current. So for I3, what is I3 here? I3 means the current flowing through the RC. So for that here we can write it as a Vx minus 0 by RC plus, and again here this current source is also the leaving current, so that we can make it as a plus alpha into I1, which is equal to 0. So here let me take here the I1 as a common, right? So I1 into here it is alpha minus 1, which is equal. So in these two what is that? Then we can make it Vx, take it as a common, so that here you will be having 1 by RB plus 1 by RC. So if you simplify this, I mean actually why we are finding, we are just trying to find Vx value. The Vx is equal to, so here I1 or 1 minus, sorry, not I1, okay. So yeah, of course I1 into here alpha minus 1, or just if you take 1 minus alpha, so here also here minus Vx is there. So minus minus gets cancelled, so that here I am just writing again. Finally here it is I1 is equal to 1 minus alpha into, if you take LCM, so RB RC by RB plus RC. So as we know, first we are going to find H11. So here H11, which is equal to V1 by I1 at V2 is equal to 0, because we are making the output terminal as a short circuit, right? So finally actually we have to get this equation in terms of V1 by I1, right? So actually now let me find here what is V1. Okay, so what is V1 here? V1 is the voltage across these two terminals, right? So what is the current here? It is I1. Okay, so V1 is equal to I by R, right? So then we can find here I is nothing but here I1, right? So then we can write it as V1, which is equal to Vx plus I1 into RA by I1 at V2 is equal to 0, right? So here we know the value of Vx, and how you know the value of Vx? Vx in terms of I1, so that we can eliminate the Vx, so that from this equation we can try to get the value of V1 by I1. So here then if you substitute here, then it will become 1 minus alpha into I1, again here RB RC, okay, by RB plus RC into I1 plus, again here where it is, yeah, again here RA into I1 is there. So RA into I1, which is equal to V1, right? So if you send this I1, I mean take I1 as a common, if you send to this side, okay, then here V1 by I1, okay, which is equal to 1 minus alpha into RB RC by RB plus RC plus, again here it is RA, right? So we know what is V1 by I1 here. V1 by I1 is equal to H11. Then here H11, which is equal to 1 minus alpha into RB RC by RB plus RC plus RA, right? So this is how we can find the H11, right? Then now we need to find the value of H21, right? So to find H21, again what is here H21? H21, which is equal to, here it is I2 by I1. H21 is I2 by I1. So which means we have to find the equation so that we can get the I2 by I1 value. So from that we can find H211, right? So how to get this I2 by I1 at V2 is equal to 0 again, right? V2 is equal to 0 again, right? So for that here, what I'm going to do is apply KCL at node Y. So this is the node Y, at node Y, right? So what are the currents here? I3 is there, I2 is there, and again alpha I1 is there. So okay. So what are the entering currents here? The two are the entering currents, which is I3 and alpha I1, and I2. Sorry, of course I2 is also entering current. So all are the entering currents only. So let me write here alpha I1 plus I3 plus I2, which is equal to 0, right? So here now alpha into I1. Actually, what we have to find? We have to find which is okay. Let us remember. Let me write here. So H2 not H21, H12. Okay. So H12 which is equal H21 only. Yeah, H21 which is equal here I2 by I1 at V2 is equal to 0. H21, right? So then here I2, of course here I1 is there, I2 is there, but I3 is also there. So we have to eliminate the I3 value. So for that what we can do is here alpha into I1 plus here I2 plus what is I3 here? What is I3 here? So I3 here we can write it as Vx minus 0 by Rc, which is equal to 0. Okay. So because here Vx minus, of course here the source, what is it, the voltage here 0 we are making. So Vx minus 0 by Rc is equal to 0. We know the value of Vx here. Okay. So Vx in terms of V1 that we know. So just substitute the value of Vx here, then alpha into I1 plus I2 plus here in the place of Vx, okay, just now we have calculated, which is I think 1 minus alpha into I1 into RB RC by RB plus RC, which is equal to 0, right? So if you take I1 as a common from here and then send I2 to the what is the right hand side, okay, so that you can find finally here I2 by I1, which is equal to minus alpha into RC plus RB by RB plus RC. So this is how you can find the value of which is H21, right? So here the only important thing here it is we should know how we can find what are the two parameters that we can find by making the output terminal as a short circuit. So those two parameters are, one is H21 and another one is the H11. These two parameters that we can find by making the output the terminals as a short circuit, which means the output voltage is equal to 0, right? Then now let me find the other two parameters. So the other two parameters are H22 and H12. Then how to find these H22 and H12? By making the input terminal as a open circuit, because before it was by making the output terminal as a short circuit, and here it is by making the input terminal as a open circuit. So by making the input terminal as a open circuit, now we have to find the value of H22 and H12. Then let me see here how to find. So here first we should know what is mean by what is the equation for these H22, okay, and H12, right? So here this is the circuit which we are going to use to find the other two parameters, which are, let me write here, which is H22 and H12. These are the two parameters that we are going to find, right? So for that here, the same way, let me apply the KCL at node Y. So here, of course, anyway, I1 is equal to 0, which is the current flowing through the RA, okay, and RB is there. So here, let us consider here the voltage is V1 and V2 here, because anyway here it is V1 is there and here it is V2 is there. So which means here the voltage is V1, okay, and here V2 is there. So that's why here the voltage is V2, right? So then here the current flowing through the RB, here it is VB by RB plus V1 minus V2 by RC, okay, plus again here alpha into I1 which is equal to 0. Right. But anyway here since I1 is equal to 0, why? Because this is the open circuit. So that's why this parameter will get into the 0. So then here V1 by RB, sorry, here it is not VB, here it is V1. Because anyway this voltage, because by neglecting this here you will get the V1. So V1 by RB plus here V1 by RC minus V2 by RC which is equal to 0. Actually, why we are writing this equation? To find here H12 which is equal to V1 by V2. Okay, at I1 is equal to 0. Right. Of course, anyway here V1, V2 are there. So let me take here, just send V2 this side and take the V1 as a common. So if you take V1 as a common, here it will be 1 by RB plus 1 by RC which is equal to V2 by RC. Right. So V1 by V2. So just send this side and this one to this side. Okay. So that you will get here V1 by V2 which is equal to, here it is RB plus RC. Okay. RB plus RC. Right. So otherwise here if you simplify this, then you will get finally here V1 by V2 which is equal to RB by, because RC gets cancelled, RB by, so here RB plus RC which is equal to H12. So this is how we can find the value of the H12 parameter. Right. So now again what we need to find? We need to find the H22 parameter. So then how we can find this H22 parameter? Okay. So just apply what is that the KVL to this particular loop. Okay, KVL to this particular loop. So here if you apply the KVL to this particular loop, let me start with the V2. So minus V2 plus RC into alpha I1 plus I2 plus alpha I1 plus I2 plus RB into I2, because here again the RB is there. So RB into I2 which is equal to 0. Right. Actually what we have to find, we need to find H22. So H22 is equal to here I2 by V2. So finally we have to reduce this equation as a I2 by V2. Of course that we can do, because here we need to eliminate I1. But anyway again here I1 is equal to 0. Okay, because I1 is 0. So that's why we can eliminate this one. So that we can just send this V2 here. So here it is RC I2 plus RB into I2 which is equal to V2. Right. So if you take I2 as a common, then you will get RC plus RB which is equal to V2. Then here it is I2 by V2. So just send this one. Right. Then here I2 by V2 which is equal to, you just send this one to other side. So that here 1 by RB plus RC. So which is equal to H22. This is how we can find the value of the H parameters. Right. So the only important thing here is, to find the value of the H parameters which are H11 and H21. Okay. So we have to make the output terminal as a short circuit, and to find the other two parameters which are H22 and H12. So we have to make it open the input parameters, which means here this we can find by making I2 is equal to 0. Sorry, short circuit. So here it is V2 is equal to 0. And here it is by making I1 is equal to 0, which means here the output terminal is a short circuit and here it is the input terminal as a open circuit. Right. Then now going to the second problem. Right. So to just understand the procedure, I didn't consider any values in the previous problem, but here we are considered the values for the resistors also. So this is a simple T network. Right. So for this T network, we need to find the H parameters. So as usually the same procedure here, first to find the H parameters which are called H11 and H21. So we are making V2 is equal to 0, right? And similarly, to find H22 and H12, so we are making I1 is equal to 0, which means here the output as a short circuit. Okay, and here the input terminals are the open circuit. So these are the conditions like in the previous case, right? So first to find these two parameters, so let us make it the output terminals as a short circuit so that V2 is equal to 0, right? So then now let us consider this circuit. Yeah, this is the circuit. So here the same way, so first we need to find H11. So H11 is equal to V1 by I1. Okay, and then what is that 21, which is equal to I2 by I1, right? So first V1 by I1. So how we can get V1 by I1 from this circuit? Okay, so very simple. First let me find the total current I1 here. Okay, in terms of V1, right? So how to find the total current I1 in terms of V1? I is equal to V by R. So anyway V1 is there, and the R means the total resistance of this particular circuit, right? So for that here V1 is equal to, okay, so here I1 into R, right? So here 4 ohms and 8 ohms are in a parallel. Are this, let me write here. Here this 2 ohms plus this 4 ohms and 8 ohms are in parallel, right? So if you simplify this, R2 plus, let me write here, 4 into 8 by 4 plus 8 into I1. So which is equal to here 4.6 into I1, which is equal to V1, right? Then send this I1 to this side. Then H11, which is equal to V1 by I1, which is equal to 4.6 ohms. This is how we can find H1. Very simple. Then to find what is that H21, which is I2 by I1. Okay. So now we know from this. Okay, from this equation we can find I1. So I1 is equal to here V1 by what is that 4.6, right? So then we can find here I1 already we know. Okay, we can find the I2 value in terms of I1, right? So what is the current division? So here I2, which is equal to here I1 means here this same I1 is flowing through this R. This is the total current. Let us consider I1. Okay, and this is, let us consider some I2 dash, and this is I2. So if you want to find I2, then the total current here it is I1 into the opposite resistor here it is 8 by 8 plus 4, right? Then send this I1 to this side. Then I2 by I1, which is equal to minus 2 by 3. Okay, which is equal to minus 2 by 3. Of course, anyway, this here I2 is minus I2 because here the direction is opposite direction that we are considering the I2 current direction. So that's why here minus I2. So that I2 by I1 is equal to minus 2 by 3, which is equal to H21. So this is how we can find the H21 value also. Very simple. See, right? The same way, if you want to find the other two parameters, which are H12 and H22, right? So here H12 and H22. So again, what we are doing, what we have to do, we have to make it the open, the primary side as a open circuit. Okay, we are making the I1 is equal to 0. By making I1 is equal to 0, we can find the other two parameters H12 and H22. So here, what is H12? H12 here it is V1 by V2, and similarly here H22 is equal to I2 by V2. Then how to find this one? Okay. So again, this is also simple. Okay, you just what is that? Apply the voltage division rule. Okay, so by applying the voltage division rule, you can find or you can get V1 by V2, because voltage division rule is nothing but because here this is the V1, the voltage across 8 ohms, right? And this is the V2. So we need to find the V2. So for that here V1 is equal to 8 by the total voltage is here it is V2. So 8 by where we need to find? We need to find the voltage across the 8 ohms resistor. So 8 by 8 plus 4 into V2, right? Then send V2 this side. So here V1 by V2. Okay. So which is equal V1 by V2, which is equal to here 2 by 3 into 2 by 3 This is H12, right? Then similarly, okay, similarly here, if you want to find the V2, then V2 is equal to here, of course, anyway, this will become 0, this part, right? So V2 is equal to what is the total current? Here it is I2. So I into R, I2 into here 4 and 8 are in series. Okay, 8 plus 4. Then send this V2 to this side and this one to this side. So 8 plus 4, 12. Then here H22, which is equal to I2 by V2, which is equal to 1 by 12. This is how we can find H2. Very simple, right? So this is the way to find the H parameters. Suppose if you are having a pi network, okay, then how we can find these H parameters? That we will see here, right? So this is the pi network. So for this pi network, again we need to find the H parameters. Okay. So of course we can do in both ways. As usually you can consider the pi network and the same way because first we need to find H11 and H21, right? So by making here I2, not I2, sorry, here by making V2 is equal to 0, and the other two parameters here it is H12 and H22. So here it is by making I1 is equal to 0. Otherwise, what we can do is, so here this is the delta network. So this delta network can be converted into the star, right? So how we can convert this one into the star? Like this. Right? So if let us consider here it is R1, R2 and R3, right? So here R1 is equal to, anyway, because this delta network having the same equal resistors, okay, so that's why we can make it as a 12 by 3, which is equal to 4. Similarly here R2 is equal to also 12 by 3, which is equal to 4, and R3 also here it is 12 by 3, which is equal to 4 ohms. So now we are converted, what is that, the star into, outside the delta into star. So which means we are converting the pi network into the T network. So now the same as usually in the whatever the procedure that we have followed in the previous problem, the same procedure we can apply to this particular network so that you can find the value of the various parameters, the various H parameters, right? So of course here for your reference purpose, I'm just drawn the circuit also. So here in this way, for this circuit we can find H11 and H21, right? And for this circuit here we can find H12 and H2, right? So here also the same way, okay. So you just what is that? Find the total current or the total voltage V1 is equal to here I1 into, again these two are what is that, parallel. Okay, so which means here 4 plus, of course, the parallel combination here it is 2. Okay, so here it is I1 into what is the, here it is 6 and V1. So V1 by I1, which is equal to 6. Right. The same way we can find the other thing also. Right. So what is the other thing? So suppose if you want to find the I2, because here we need to find what is that, I2 by I1. So here I2 is equal to the total current, here it is I1 into what is the opposite resistor? 4 by 4 plus 4, right? So here it is I2 by I1. So I2 by I1, which is equal to here 4 by 8, so 1 by 2, right? So which means 0.5, right? So then now here, okay. So here this H12 and H22. So here H12 is equal to V1 by V2, and here H22 is equal to I2 by V2, right? So V1 by V2 means, again let just apply the voltage division rule. So here it is V2. So which means here V2 is equal to the V1 is equal to, sorry, V1 is equal to the total voltage, here it is V2. Now we need to find across the 4 by 4 plus 4. Then here it is what is that, V1 by V2. So just send here V1. So V1 by V2, which is equal to again 1 by 2. The same way other thing also you can find. So this is how we can find the H parameters, right? So are also called as a hybrid parameters. Only the thing that we should remember here it is to find H11 and H21 we are making V2 is equal to 0, which means we are making the output voltage terminal or the output terminals as a short circuit. And to find the H12 and H22, okay, so we are making I1 is equal to 0, which means we are making the input terminals as a open circuit. So in this way we can find the hybrid parameters, right? So in the next class we will discuss the next topic.
Like, share and subscribe. Hit the bell icon for more updates.